Today's Automation Tips webinar, which is centered around Cloud to Factory 4 robot path planning. My name is Jeremy, and I'm the education lead here at Vention. And my role essentially is to educate users on how to use Vention's design software, which is Machine Builder, as well as the simulation and programming software, which is MachineLogic, that all lives within the same environment. With that, I'm going to jump directly into the agenda to see what we will be covering today. So for today, there are 4 different topics that I would like to cover. The first is being able to show you guys how to configure your collaborative robot. Second, how to create a local sequence. Third, create a global sequence. And finally, how to use arrays all within MachineLogic. So the purpose of today's webinar is to get you guys up to speed and show you how easy it is to program a six-axis collaborative robot directly within MachineLogic, and showcase that it is robot agnostic with the few collaborative robots that we do have on our platform. Throughout the presentation, if you'd like to interact, there are a few different ways you can do this. The first is through the Q&A section at the bottom of the Zoom platform. You can ask questions that will be seen throughout the presentation and can be answered live if they are relevant. And finally, secondly, there is also the ability to chat with other participants in the chat section. Finally, at the end, there will be a portion where we will unmute everyone to give everyone a chance to ask questions as well. So one thing to note, my colleague Alfred is on the line and will be monitoring both the Q&A and the chat section, so feel free to ask them. And if they are not answered throughout the presentation, they will be answered at the end, if not in an email as well. One final note is this session is being recorded and will be sent out to all participants that have registered and signed up. So with that, I'm actually going to close the presentation over here and jump over to the design that we will be looking at throughout the rest of the presentation. So what we see on screen here is a machine tending cart. So essentially, the purpose of a machine tending cart is to replace a repetitive use action usually seen in factory floors for, say, tending CNC machines. Purpose would be, say, pick up a part, place it in CNC, wait for it to be done, and replace it with an unfinished part. In our case, what we'll be doing is focusing a bit more on creating a more simple application, which is going to be a pick and place. So the purpose will be to pick up a part at one location and drop it off in a secondary location. Really, for the sake of time, we're going to stick with something a little bit simpler, but if you do have any questions about creating something more complex, feel free to ask them throughout the presentation or at the end, and we can see if we can create something a bit more complex that can be sent out to all attendees as well. So the first thing to note is that there are 3 different robots that you can actually use the robot path programming for. If you go over to the robots section in Machine Builder, which is the environment that I'm currently in, you notice we have 3 different collaborative robots here. We have the Doosan H series, the Fanuc CRX, as well as the Universal robot series going from the UR3 all the way to the UR16E. So the MachineLogic program that we will be writing actually functions for all 3 of these robots. The only thing that you need to do is either bring in a robot into your design to be able to access the MachineLogic tab. Again, this has already been done for us just for the sake of time. And then after doing this, you can also add one of the grippers. So if you go back into the robot end of arm tool, you'll see that we do have quite a wide selection of robot grippers from either Shunk on robot, as well as some vacuum grippers from Joulin. In our case, we opted for the 3-finger gripper, which is mostly used for picking up objects that are cylindrical in shape. So now that you have your robot and your end of arm tool in your design, what you can do is change over to the MachineLogic tab at the top of your screen. From here, it will just load up into the configuration page. So if you are a little bit more familiar with MachineLogic, normally if you're creating a Vention machine, you would go over and click on Add Actuator. In our case, since we are programming a robot, we're going to click on Add Robot. Again, I will be highlighting some of the similarities between the robot path programming and standard Vention MachineLogic for Vention actuators, since they do share a lot of parallels. So once you click on Add Robot, you can select the model of robot that you have in your design. If you have multiple robots in your design, you can only program one of them at a time at the moment. So if you'd like to program multiple, it is recommended to have them or split them up in different sections. Oh, no sound. Oh, I think that might have been a little bit earlier on. Just double checking that you guys can hear me. That was sent to, oh, perfect. Thank you very much. Sorry about that. So again, in our case, I will be clicking on the UR model that I have in my design over here and let that load up. So you see the loading icon that we have over here is really just allowing the system to sync up with our simulation servers that we have here at Vention. So once that's done, you have the ability to rename your robot. In our case, I'm going to be calling it UR5 since it is the UR5, and then select the end of arm tool. Again, it automatically fills out the type of gripper that you have attached to your robot in your design. So I'll click that, and then you have the pinout options. Again, over here, this is a bit more applicable to the real life deployment of your machine. And I would recommend changing the pin option, so either going from 0 to 1 to match the real life deployment. But for the simulation portion, really is not necessary and can be changed at the end. So that is essentially the first step, which is configuring your robot. From there, we can go over to the visual sequence to actually start creating our application and building a program out for it. So again, similar to standard machine logic, in order to create an application, you go down to the bottom over here. For robot programming, we have two options at the moment. You have a prefabricated machine tending application, which can function for what we're trying to do. But since I want to showcase how easy it is to create something custom, I'll be clicking on Add Custom Application. From here, again, just highlighting some of the similarities, you have the ability to rename your application as well as go through some of the sequences. So first off, I will rename the application that I will be creating and call it Pick and Place. Confirm, you can press enter and you'll see that it changed from new application to pick and place. From here in the robot assets, this is where you'll see some of the three major things that you will be using when programming and deploying your robot. First are the robot paths, robot arrays, as well as the digital calibration tools that you have in your design. For now, I'll leave those as is and we'll highlight them a little bit later on. From there, we'll be going down to the sequences. So again, this is the exact same as standard machine logic programming, and that you have your main sequence where you essentially build out and assemble your program. And then if I go down to the bottom and click on add sequence, you have child sequences, which are essentially the individual functions or actions that you call within your main sequence. So from here, that is the highlight of the standard machine logic interface for robot programming. And we can actually go ahead and start creating our first robot path. So there are two different locations that you can create a robot path. The first is in the child sequence or the main sequence itself. And what this does is it creates a local sequence. What local sequences are essentially sequences or programs that are meant for one-time use actions. So for example, if you're programming it out here, you can only call it within the child sequence or within the main sequence once. The other option is to create one in robot assets. So if you go over robot assets over here and click on add robot path, what this does is it creates a global sequence. And this functions very similarly to variables that were covered in the previous webinar that can be called at any time throughout your program. Again, I'll be creating one to begin with as a child sequence, so creating a local sequence, and then transitioning it to a global sequence to showcase how it can be used later on. So the first thing that we're going to do is actually rename our child sequence to pick 1. And then press enter to confirm, and then add command. Again, the interface is very similar. All I have to do is click on add robot path. So from here, before I actually get programming, I'll highlight some of the interface that we have over here. So the first thing you can do is rename the robot path if you'd like. Again, since I'm doing pick 1, I'll rename it pick 1 path since it lives under this child sequence. Then from the drop-down menu, make sure that you have the proper robot selected. From there, moving on, we have the reference frame. So I can click on the information over here. If you'd like to get a little bit more information, we do have a extensive command glossary for a lot of the programs and actions within machine logic. But essentially, the reference frame is the frame of reference used when creating or teaching waypoints. So essentially, the waypoints are the points in space that you would like to have your tool or your robot travel to. And the reference frame essentially is the origin point of your base coordinate system that you will be teaching your robot. Normally, when you create a robot path, the default reference frame is at the base of the robot. In our case, I'm going to change it to the base or the top of one of the first parts that we plan on picking up. So you can actually change the reference frame to any point you'd like within your program. One thing to note is if you have it too far outside of the reach of your robot, it might affect the ability for your robot to complete the desired path. So once we've created or edited our reference frame, we can start off by creating the program itself. So you see here that we have two different commands. The first is to add a waypoint, which, as I previously said, are the points that you would like to have your tool center point, or your TCP for short, to travel to. Tool center point is essentially the center point at which all of the fingers would converge to, be it a 3-finger gripper, 2-finger gripper, or any other type of gripper that you have. The other type of command that you can execute is the add robot command, which I'll be adding just in a second. So from here, I'll delete this one and restart. So first, I'm going to add a waypoint. Now, there are 3 different ways that you can move or edit the waypoint itself. The first is with the triad that you see on screen over here, very similar to moving parts around in MachineLogic or even editing the robot if you right-click on it. You can drag it around in each of the axes, any of the planes, or rotate them around the axes as well. The second is using point-to-point. Point-to-point functions are very similar to point-to-point connection tool that we have in Machine Builder, which essentially snaps the tool center point to a specific area in your design. The third one is using the jogger. What the jogger does is allows you to modify or edit the position of each of the joints individually, either using the slider, arrow keys, or by inputting a specific value. And then finally, you can actually edit the tool center point location with respect to your reference frame. You'll see I have 0, 0, 0, since that is now hovering over the exact reference frame that I had created earlier. For our case, I'll start off by using the point-to-point to snap it to the part. So this really gets it over the part I would like to pick up, and use the triad to actually edit its, edit its position. So again, I'll do point-to-point, snap it to the location, and then using the triad, I'll drag it up to function or to a cruising altitude. From there, I can confirm the waypoint. And notice once I've done that, you'll see a green dot appear within the MachineLogic window, or pardon me, within the design window. This essentially showcases where the waypoints are, and if you have separate actions as well, it shows what type of action is being executed at that point. So from there, I can add another waypoint, again, using the point-to-point jogger, and bring it down to the tool to confirm. So this, one of the great things about programming with MachineLogic, again, either if you're using the robot path programming or programming a standard Vention actuator, is that you're not set in stone with what you've created. Say, for example, over here, I realized I've brought my tool down to the part without actually opening the gripper first. So what I can do is add a robot command, have the gripper move to its open position. You notice it does change or adds a second command next to this waypoint here. But what I really want to do is make sure that it's open before it goes down. So I'll drag it up, and now you notice that it will open the position at the top point before moving down. So from there, I can run through my program. So I have it start at the top, open the gripper, move down to the bottom, and then I can add an extra robot command to close the gripper. From here, I will move the robot back up to its cruising altitude and confirm the waypoint. So as you click through them, it does allow you to snap the robot to that position, and you can use that to actually edit your waypoints a little bit faster. For the rest of this program, what I'll be doing is just speeding through the programming of having the robot move over to a secondary location, move down, drop off the part, and then move back up to a cruising altitude. So I'll add waypoint, point-to-point jogger, secondary location over here. Again, drag it up. So there are 2 different options. You can drag it up using the triad that I've seen here, but you will sometimes end up with the robot at a different height from the original cruising altitude. So that you can also go into the jogger at the first point to see what its Y position is. In my case, just for ease of use, I'll continue using the triad and the point-to-point connection tool. Dropping it down, adding a robot command to open the gripper, which will then drop off the part at this location. And then one final move to bring it back up to its cruising altitude. So this, I'll run through the program to see what it looks like. So we start off with the robot at the first position, opens the gripper up, moves down to the part, closes the gripper to actually grab onto it, moves it back up to our cruising altitude, over to the second drop-off location, brings it down, opens the gripper to let go of the part, and then finally back up to its cruising altitude. So this, we can go into the main sequence to actually build out the program, but before I do so, I'm going to highlight some of the things that I did skip over. The first that we have here is the path type. So the path type essentially dictates how the robot will move from one point to another. So this, you have 2 different types of move, move J and move L, which are the industry standard when programming robots. Move L essentially has the robot move in a linear, or has the tool center point, pardon me, move in a linear fashion from one point to the other. So if I highlight this over here, you'll see it'll give a brief example. So you'll notice the tool center point is moving in a straight line from one point to another. If you have move J, it essentially allows the robot to move in any direction it would like, as long as the tool center point gets to its secondary location. So if I highlight this, you'll notice the robot moves in more of a curved path to get from one point to another. Usually move L is a recommended type of move, but really is dependent a little bit more on your type of application. The other thing here is fixed waypoint. This I'll cover a little bit more once I go into global reference frames. But essentially what fixed waypoint means is it will choose to use the reference frame of the global sequence that we will create in the future instead of the local reference frame of the robot path program that you have right here. So this, I'll go over to the main sequence to build out the program. So it's simply as easy as going to add command, clicking on add execution, and then selecting the sequence we would like to execute. In our case, we only have one child sequence. So I have that selected. And then to actually simulate it in real time, all you have to do is press play. So from here, it does highlight the action that it is being completed at that time. Since it is a very short program, it does run through it very quickly. And one thing to note, we do not simulate the end of arm tool itself, since it does take a little bit more computing power and everyone's computer is a little bit different. So we try to make sure to only really move the robot to the specific location. But in real life, with the commands that are written here, it would send the command to open or close the gripper at that point. So I'll press play one more time just to see that run in action. So we move down, up, over, down, and then finally back up. So the robot will snap back to its resting position. So its original resting position is over the first point. So it does snap back and stop in there at that location. So from here, what I'll be doing is showcasing how you can transition from a local sequence to a global sequence. But if there are any questions, I would kind of like open the floor a little bit now if you want to ask them in the Q&A or in the chat section as well. All right, perfect. So with that, I'll move on to the second portion, which is creating a global sequence. So moving over here, you notice that I do have the option to save to robot assets. So what this allows me to do by clicking this, it changes my local sequence that I've created to a global sequence. What this gives me the ability to do is then call this type of sequence in other child sequences later on in my program. Say, for example, I'd like to have a program repeat the same action, but at the secondary part over here. I can, pardon me, create the entire sequence that I have here, replicate it, say by creating all of the waypoints again, doing the point-to-point connection, moving the triad, but this is a little bit more time consuming. By creating a global sequence with this, I can actually do this in a few easy steps. I can first go to add sequence. I'll rename this pick 2, and then click on add command. So now if I add a robot path, I have the ability to select first from any of my global sequences that I've already created, or create a new sequence. So creating a new sequence will let me go through the process that I just did. In my case, I'm going to leave it as the pick 1 path. The one thing that I do have to change if I would like to have the pick position be different is edit the local reference frame. So I'll click on edit and select the location over here. So now if I zoom out, and then run through the points, you'll notice that it is now going to pick up at the second part location and drop off at the secondary drop-off location. So this is very good if you have a few repetitive type of actions to complete, but not too many. So this, I'll go back to main sequence, add command, add execution, and then select pick 2. So this should work. It will then execute the pick 1 position and then pick 2. I'll press play to see it simulate. So after executing the first, it will then move over to the secondary position and execute the second. Again, to get a better view, I'll do a top view and zoom in a little bit and press play one more time. So we have pick up at the first, move over to the second. Once that's complete, we'll then move over to the new child sequence that I've created and pick up at the second and drop off at the second location. So from here, that covers the third point, which is creating a global sequence. The last thing that we're going to look at are creating a robot array. So robot arrays are very useful when you want to have a highly repetitive action. So right now, say we only have 6 parts on the tray. If I add 30 or 40 parts on the tray, which is not uncommon when using a machine tending application, Creating 30 or 40 child sequences can create a little bit of a complicated program. To get around this, you can create arrays. What this allows you to do is then have this sequence play over and over, but with different origin positions. So you go over to robot assets, click on robot arrays, and then click on add robot array. So from here, you do have to first select your reference frame or your origin position for your array. Again, this is recommended to do the first part that you plan on picking up, since that is the way that I've created my original picking path. From there, you select the type of array. At the moment, we only have fixed spacing, and you can rename it if you'd like. In our case, I'll name this picking array. In my case, I'd like to have it pick up at 4 different locations. So I like to have the first position that I've already selected, secondary one over here, third, and then fourth. So this, it'll be a 2x2 array. And then from here, you have to then select the spacing that you would like to use. In my case, I'm gonna have the spacing between columns is going to be minus 90 millimeters. The reason being, if you see the array arrow is pointing right, so that's a positive direction. So to have it selecting the one on the left over here, I would do negative 90. And then the spacing over here will be 225. So that is spacing between the first part and the second part over here. From there, you can click on generate array, and it will showcase the points that will then start at the robot path. So it'll start first at the reference frame and then move over to the first point, second point, and then third point. If you'd like to reorganize how these points are picked, you can actually, again, simply drag and drop to the new location, similar as you can do with the commands. If you're happy with your array, you can click on Done to complete. Now we can actually go back to the main sequence to actually program out the array action itself. So going over to the main sequence, the major difference here is instead of using add execution, what we'll be doing is adding a loop. So essentially what the loop does is it has the robot loop through the type of sequence that I'd like to use, which is the pick sequence, throughout the entire array. So I only have one array, so I'll select that one. You notice now it highlights all of the moves that it's going to complete, even the move between the end position and the secondary or tertiary start position. So this, it's as easy as pressing play to actually have it run in real time. I'll do a top view to actually see, you can actually see the robot move from the various locations. Also right now, as this plays, if you do have any questions about, say, anything that you've seen, feel free to ask now as well. So from there, picked up at the first location, dropped off at the first drop-off location, and then repeated for the other 2 or 3. So right now, for this array, I really only had 4 locations. So it wasn't, say, like the most useful for this one. But again, like I said, if you have a tray with, say, 30 or 40 parts, it does get a little bit complicated to create a pick location or a pick sequence for each of those individual parts. Another very useful thing that are great for arrays is the ability to translate them to different planes. So right now I've created this array only for this top tray, but if the other 3 trays also had parts, all I have to do is change the reference frame or create a new array with the reference frame at a secondary or tertiary location, and it would be able to replicate these actions again at either of the other trays. Once you are happy with your program, one of the great things that you can do is actually download it directly from MachineLogic as a script and upload it to your robot controller of choice. To do that, you go to the download or download icon on the left, click on that and click on download application. What this will do is we'll download the script with the type of robot in mind that you've programmed it for. So in this case, if I have a UR in the design, it will download a UR script. If I have a FANUC CRX, it will download a script that the CRX is able to understand. And again, same for the Doosan H series. One of the great things is the programming interface that you see here is the exact same for all 3 robots. The final thing that I'd like to touch on for this is the ability to actually deploy this with ease. So you'll notice in the design here, I have this extra part, which is the digital calibration tool. You have one at the end of arm of the robot, and then one on the tray itself or close to the picking location that you have. One of the great things is if you are deploying your robot on a Vention structure, if you've assembled it almost exactly, all you have to do is place the calibration tool in the same location that you have in CAD as in real life, and then calibrate it by mating the end of arm tool part with the calibration tool And then once that is done, you can simply press play to actually have the robot run in real time, the exact same script that you've programmed in MachineLogic. In the past, we actually do have a live example of this on our website if you'd actually see this being done in real time. But essentially, I have covered everything that I want to show, which is creating simple arrays, configuring your robot, creating global arrays, and robot pass sequences within MachineLogic.